Alright, time to look at the dynamic array source code. This is part 2 of 2 in the array series. So the source code for this video can be found at the following link: github.com/myusername/data-structures. Also make sure you saw the last video so you know what's going on with this array implementation. Alright, here we are in the array class. So I've designed an array class to support generics of type T. So whatever type of data we want to put in this array, that's fine. So here are our three instance variables that we care about. R, which is our internal static array. Len, which is the length the user thinks the array is. And capacity is the length of the actual array, because sometimes our array might have more free slots and we don't want to tell the user that there's extra free slots that are available. That's just our internal knowledge. So there's two constructors. The first one will initialize the array to be of size 16. The other one, you give it a capacity. The capacity, of course, has to be greater than or equal to 0. And then we initialize our array and cast it to a type T. Also notice that I need to put this suppress warnings unchecked just because of annoying generics in Java. So here are two simple methods: size, get the size of the array, and check if the array is empty. Pretty self-explanatory. Similarly, for get and set, we just index into the array if we want the value, or set it if we want to set the value. Technically, I should be doing a bounds check for both of these, but I'm not, apparently. Okay, clear. So here we just remove all the data in our array and reset the length. Simple. This next one is the add method, where things actually get a little bit more complicated. So this condition says, hey, if the length plus 1 is greater than or equal to the capacity, then it's time to resize my array. The way I'm resizing is I'm doubling the size of the static array. You don't have to double the size, but I've decided that doubling the size is convenient. So when I double the size, I have to create a new array with the new capacity, copy everything in. This is what this line or these lines are doing. It's copying the old values back into this new array, and then it sets the old array to be the new array. And lastly, here we just copy the new value into our array. So this remove as method will remove a particular value at a given index. First, we check if the index is valid. If it's not, throw an index out of bounds exception. Otherwise, grab the data at the remove index, initialize a new array of size length minus 1. Now copy everything into the new array except for when it's at that remove index. Now I'm sure there's easier ways to do this, but I decided to do the following. Maintain two indices, I and j. Increment I and j as you go, but when I is equal to the remove index, then we skip over the remove index by fixing j temporarily and using j to lag behind, if you will, while I is still in the original array. So I guess pretty clever overall. And then set the array to be the new array we just generated, reset the capacity, and return the data we have just removed. So this next one, remove, we scan through the array. If we find the object we're looking for, remove it at the index and return true, otherwise return false. Index of is very similar. If you find it, return I, otherwise return -1. Contains just checks if index of is not equal to -1. Alright, this next one, I return an iterator for the array. So an iterator allows us to iterate over the array, providing an abstraction for it. So I need to override two methods, and this is hasNext. So there exists a next element in our array if the index is less than the length of the array. I should also be checking for concurrent modification here, just in case someone decides to change the array for some reason while we're modifying it. Might add that later, might not. Also, there's the next method, which just returns the next element in the array relative to the iterator. Okay, and lastly is the toString to get a string representation of this array. Nothing too complicated. Alright, so this is a very simple data structure, it's just a dynamic array. If you look at Java's array list, it looks very, very similar to this. So guys, thanks for watching, and I will catch you in the next video.